Good day, esteemed researchers and viewers worldwide. We're here to delve into the fascinating work titled Obtaining Favorable Layouts for Multiple Object Generation by Barak Batash, Amit Rosner, Lior Wolf, and Ophir Lindenbaum. This research addresses the intriguing challenge of subject neglection and blending in text-to-image diffusion models, offering a multi-step solution that enhances the generation of images with multiple subjects. Stay tuned as we unravel the implications of this groundbreaking work. In our quest to improve text-to-image diffusion models, we've focused on two key challenges: generating multiple subjects and overcoming issues of subject neglection and blending. These problems are prevalent in existing models, such as SD 2.1, D&B, A&E Sheffer et al. 2023, and SDXL Podale et al. 2023. These models often neglect subjects, blend subjects together, or even collapse to a cartoon mode when the prompt is too complex. Our goal is to address these issues and enhance the overall performance of subject appearance in the scene. We believe that by tackling these challenges, we can make significant strides in improving the quality and accuracy of images generated by diffusion models. Stay tuned as we delve deeper into our proposed solutions and their impact on the field. In this slide, we delve into the key insights and the main idea of our research. Diffusion models, while powerful, are not without their shortcomings. They often struggle with shortcut issues, such as neglecting and blending subjects and tokens. This becomes particularly problematic when the prompt is complex. However, the ability to generate multiple subjects and objects clearly is a crucial aspect of text-to-image models, enabling them to create intricate scenes effectively. Our research proposes a multi-step solution to tackle these challenges. We handle multiple aspects of the generation process, including cross, attention, and the latent space. Our approach involves a unique intervention that combines pulling the generation process during inference time using various loss terms and direct editing of the latent space. This comprehensive solution enhances the ability of text-to-image diffusion models, making them more capable of generating images with multiple subjects or objects. Stay tuned as we delve deeper into the specifics of our method in the following slides. On this slide, we're going to highlight some of the key contributions and results of our research. First and foremost, our work significantly enhances the ability of text-to-image diffusion models to generate images with multiple subjects. This is a critical step forward in the field, as it allows for the creation of more complex and realistic scenes. While our method does not directly tackle the attribute binding phenomena, it naturally aids in mitigating this issue. This means that our model can better align attribute details, such as color or texture, with their intended objects, leading to more accurate and visually pleasing images. Now let's move on to the results. Our method excels in preventing subject blending and enhancing the subject's appearance in the scene. This means that our generated images are less likely to have subjects that blend into each other, and each subject is more distinct and recognizable. Furthermore, our model improves the image layout, even when accommodating multiple objects. This is a significant achievement, as it allows our model to generate images that are not only more accurate but also more aesthetically pleasing. In summary, our research presents a comprehensive solution to some of the most pressing challenges in text-to-image diffusion models, and we're excited to share these findings with you today. As we delve deeper into the realm of diffusion probabilistic models, we come across a significant challenge: generating high-quality images with multiple subjects and objects. If you look at the figure on your right, you'll see a comparison of our method with other competitive methods. The results are striking. Our method consistently outperforms others in generating images that accurately represent the prompts. Diffusion probabilistic models have revolutionized the field of image generation. They've shown remarkable performance and wide applicability. However, they're not without their challenges. The most prominent among these are subject neglect and subject blending. These issues become more complex as the number of subjects in the image increases. Our research aims to address these challenges head-on. We believe that a well-structured layout can mitigate these issues. By manipulating the latent map and attention maps, we can generate images where the subjects are well separated and no subject dominates the scene. This is just the tip of the iceberg. As we move forward, we'll delve deeper into our proposed solution and how it outperforms existing methods. Stay tuned. In this slide, we're going to delve into the challenges faced by state-of-the-art text-to-image foundation models. such as stable diffusion, imagine, and DAL-E. These models, while impressive, struggle with certain semantic issues when synthesizing text to image, particularly when dealing with multiple subjects or objects. The three main challenges are subject neglect, subject blending, and attribute binding. Subject neglect refers to instances where not all subjects described in the input text are present in the resulting image. Subject blending is when subjects are merged into other subjects, like a bear with an elephant trunk. Attribute binding is a compositional issue where attribute details, like color or texture, are either misaligned with their intended objects or mistakenly associated with unrelated objects. Our work primarily addresses the first two challenges, subject neglect and subject blending. As you can see in the figure on the right, these issues become more complex as the number of subjects increases. Our model improves the image layout and leads to generated images that are more faithful to the prompt. In the next slides, we will discuss our proposed solution to these challenges in more detail. Stay tuned. On this slide, we have a visual comparison of our method with other competitive methods for generating images with multiple subjects and objects. As you can see, our approach significantly improves the generation process, addressing key semantic challenges in text-to-image synthesis. These challenges include subject neglect, where certain subjects in the prompt are ignored during image generation, and subject blending, where the attributes of different subjects are mixed together, leading to confusing results. Another challenge is attribute binding, which refers to the incorrect assignment of attributes to subjects. Our method effectively tackles these issues, enhancing the clarity and accuracy of the generated images. This is a significant step forward in the field of text-to-image synthesis, opening up new possibilities for creating complex scenes from textual prompts. In the next slides, we will delve deeper into our methodology and its advantages. Stay tuned. Begin our frame. Frame title our solution and its impact. Begin a mini page. T as 0.5 line width. Begin itemize. Item our multi-step solution addresses the generation process, including cross-attention and the latent space. Item we intervene by pulling the generation process during inference time, using various loss terms, and directly editing the latent space. Item our model enhances the ability of text-to-image diffusion models to generate images with multiple subjects. Item we show that our method can better prevent the blending of subjects and enhance the overall performance of subject appearance in the scene. End itemize. End a mini page. H-fill. Begin a mini page. T is 0.5 line width. Begin a figure. Centering. Include graphics. Height equals 0.8 text height. SRC task underscore execution extracted underscore paper underscore data. 2405.00791v1 figures 2405.00791v1 figure 5:1.png. Caption output produced by our method in response to the prompt. A chicken and a duck with a ball at the beach, and a dog, a cat, and a bear at the beach. End a figure, end a mini page, end a frame, begin a frame. Frame title our solution and its impact. Begin a mini page. T as 0.5 line width. Begin itemize. Item our multi-step solution addresses the generation process, including cross-attention and the latent space. Item we demonstrate our model's enhanced ability to generate images with multiple subjects, effectively creating complex scenes. Item our method also helps to prevent subject blending and improves the overall performance of subject appearance in the scene. End itemize. End a mini page. H-fill. Begin a mini page. T is 0.5 line width. Begin a figure. Centering. Include graphics. Height equals 0.8 text height. SRC task underscore execution extracted underscore paper underscore data. 2405.00791v1 figures 2405.00791v1 figure 5:1.png. Caption output produced by our method in response to the prompt. A chicken and a duck with a ball at the beach, and a dog, a cat, and a bear at the beach. End a figure, end a mini page, end a frame, begin a frame. Frame title our solution and results. Begin a mini page. T as 0.5 line width. Begin a figure. Centering. Include graphics. Height equals 0.8 text height. SRC task underscore execution extracted underscore paper underscore data. 2405.00791v1 figures 2405.00791v1 figure 5:1.png. end a figure, end a mini page, hfill, begin a mini page, t a 0.5 line width, begin itemize, item figure. Our method's output for the prompts: a chicken and a duck with a ball at the beach, and a dog, a cat, and a bear at the beach. Item. Our multi-step solution tackles the generation process, including cross-attention and the latent space. Item. Our method enhances the ability of text-to-image diffusion models to generate images with multiple subjects. Item. We demonstrate our method's effectiveness through extensive experiments, showing improved subject appearance and reduced blending. End itemize, end a mini page, end a frame, backquote, backquote, backquote. On this slide, we have a visual comparison of our method with other competitive methods for generating images with multiple subjects and objects. As you can see, our approach significantly improves the image layout, resulting in images that are more faithful to the prompt. Now, let's delve into our research hypothesis. We believe that the diffusion model inherently leans towards certain favorable layouts. This bias can be leveraged to our advantage. Furthermore, we posit that manipulating the latent map, the underlying representation of the image, is as crucial as manipulating the attention maps, which guide the model's focus during generation. By understanding and manipulating these aspects, we can effectively address the challenges of subject neglect and blending in text-to-image synthesis. This is a significant step forward in the field, and we're excited to share more about our method with you. On this slide, we delve into the three-phase solution we've proposed to tackle the challenges of subject neglect and blending in text-to-image synthesis. Firstly, we apply various loss terms during the initial denoising steps. This encourages the cross-attention maps, or XAMs, associated with each subject to be excited, yet distinct from other subjects. Secondly, we extract binary masks for each object and revise these masks to achieve more favorable layouts. This involves shifting some objects and readjusting the latent space of the diffusion model to match these optimized masks. Lastly, we continue the diffusion process, but with a twist. The process is now driven by the per-subject XAMs, matching the set of fixed masks we've previously generated. This comprehensive approach addresses multi-subject generation across all diffusion steps, subjects, and spatial locations. It's a significant step forward in improving the quality and accuracy of image generation from text prompts. Moving forward, let's delve into the core of our research. We've developed a comprehensive solution to tackle the challenges of multi-subject generation. This solution is not just a one-size-fits-all approach, but rather, it's designed to be adaptable across all diffusion steps, for all subjects, and in various spatial locations. This adaptability ensures that our method can handle a wide range of scenarios and complexities in text-to-image synthesis. Now, we didn't just stop at developing this solution. We put it to the test. We conducted an extensive set of experiments to evaluate its performance, and the results, they were remarkable. Our proposed method outperformed many existing baselines in the field, demonstrating its superior performance and effectiveness. In the next slides, we'll delve deeper into the specifics of our method and the results of our experiments. Stay tuned for a fascinating journey into the world of diffusion models and multi-subject generation. Moving on to related works in the field, let's first understand the landscape of text-to-image diffusion models. These models have been pivotal in current research, driving advancements in high-quality image generation. They've been the backbone of state-of-the-art models like Stable Diffusion, Imagine, and DALL-E. Now let's delve into one such model, SD 2.1. This model uses a unique approach to generate images from text. However, it's not without its limitations. The most significant issue with SD 2.1 is subject neglection, where not all subjects described in the input text are present in the resulting image. It also suffers from subject blending to a lesser extent, where subjects are blended into other subjects, creating a confusing image. In the next slides, we'll explore more models and their unique challenges, as well as our proposed solutions to these issues. Stay tuned. Backquote, 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 begin a frame. Frame title SDXL Podale et al. 2023 Model and our method. Begin itemize. Item SDXL Podale et al. 2023 Model. Begin itemize. Item key features. Sometimes collapses to cartoon mode when the prompt needs too many compositions. Item drawbacks. Subject blending and object neglect, as seen in the generation of ducks with frog attributes and the absence of a dog in the first row. End itemize. Item our method. Begin itemize. Item strengths: better prevention of subject blending and enhancement of subject appearance in the scene. Item examples: successful generation of images in response to complex prompts like a chicken and a duck with a ball at the beach, and a dog, a cat, and a bear at the beach. End itemize, end a frame, begin a frame title our approach and results, begin itemize, item our model's approach, begin itemize, item we've developed a multi-step solution that addresses several aspects of the generation process, including cross-attention and the latent space. Item our method pulls the generation process during inference time using various loss terms and directly edits the latent space. End itemize, item our model's performance, begin itemize, item our model excels in generating images with multiple subjects, a critical ability for text-to-image models. Item it creates an improved image layout that accommodates all objects, preventing subject blending and enhancing the overall performance of subject appearance. Item figures 5 and 6 illustrate our model's superior performance in generating complex scenes effectively. End itemize, end a frame, In our work, we've taken a multi-step approach to address the challenges in the generation process. We've focused on aspects like cross-attention and the latent space, pulling the generation process during inference time using various loss terms, and directly editing the latent space. Our model has shown promising results. It excels in generating images with multiple subjects, a critical ability for text-to-image models. It creates an improved image layout that accommodates all objects, preventing subject blending and enhancing the overall performance of subject appearance. To illustrate this, let's take a look at figures 5 and 6. These figures demonstrate our model's superior performance in generating complex scenes effectively. As you can see, our model is a significant step forward in addressing the limitations of existing models. Let's delve deeper into the technical aspects of our research. On your left, you see a figure comparing the image generation outputs from our method and other competitive methods. This comparison is based on multiple prompts, each with varying amounts of subjects and objects. Now, moving on to our proposed research. Our primary aim is to tackle two significant issues in text-to-image diffusion models: subject neglect and blending. These problems become more pronounced as the complexity of the prompt increases. To address these issues, we propose a multi-step solution. This solution handles multiple aspects of the generation process, including cross-attention and the latent space. By pulling the generation process during inference time and directly editing the latent space, we can significantly enhance the ability of these models to generate images with multiple subjects. In essence, our method improves the overall performance of subject appearance in the scene, making it possible to create more complex and accurate images. Stay tuned as we delve into the specifics of our method in the upcoming slides. On this slide, we delve into the technical details of our research. We begin by addressing the problem at hand: subject neglect and blending in text-to-image diffusion models. This issue becomes more pronounced as the complexity of the prompt increases. To illustrate this, we have a figure on the right that compares the image generation outputs from our method and other competitive methods for multiple prompts. This figure showcases the varying amounts of subjects and objects in each image. As you can see, the problem of subject neglect and blending is quite evident in the images generated by other methods. However, our method shows a significant improvement in handling multiple subjects and objects, thereby creating more accurate and complex scenes. This comparison underscores the need for our proposed solution, which we will discuss in the following slides. Stay tuned as we unravel the intricacies of our method and how it enhances the capabilities of text-to-image diffusion models. As we delve deeper into our research, let's take a look at this figure on the left. It compares the image generation outputs from our method and other competitive methods for multiple prompts, showcasing various amounts of subjects and objects. Our approach to this problem is twofold. Firstly, we pull the generation process during inference time using various loss terms. Secondly, we directly edit the latent space. This dual approach enhances the ability of our model to generate images with multiple subjects, a critical ability for text-to-image models. Now, let's turn our attention to the image on the right. This visual representation further illustrates the effectiveness of our method. As we move forward, we'll discuss some limitations of our approach and how we plan to address them. Begin a frame. Frame title: a visualizing the process and results. Begin a mini page. T as 0.5 line width. Begin itemize. Item figure. Our method's response to prompts and attention maps at a crucial generation step. Item attention maps and their role. Begin itemize. Item step 9 in the generation process significantly impacts the image layout. Item visualization of attention maps aids in understanding their importance. End itemize. Item comparison with baselines. Begin itemize. Item our model generates improved image layouts accommodating all subjects. Item baseline models often produce cartoonish images or neglect objects. End itemize. End itemize. End a mini page. H fill. Begin mini page. T as 0.5 line width. Begin a figure. Centering. Include graphics. Height equals 0.8 text height at src task underscore execution extracted underscore paper underscore data 2405.00791v1 figures 2405.00791v1 figure 5 to 6.png. Caption our method's response to prompts and attention maps at a crucial generation step. End a figure, end a mini page, end a frame, On this slide, we have a figure that compares the image generation outputs from our method and several competitive methods for multiple prompts. These prompts are designed to showcase various amounts of subjects and objects. Our experimental design expands on previous benchmarks by examining text-to-image models in more extreme cases. We've used prompts with at least 2 subjects as templates to push the boundaries of these models. To ensure a comprehensive evaluation, we've used over 700 prompts, each generated using 5 different seeds. This rigorous approach allows us to thoroughly test the capabilities of our method and compare it effectively with other models. In the figure, you can see how our method performs in comparison to others, highlighting its ability to handle complex prompts with multiple subjects. This is a key aspect of our research, and we believe it significantly advances the field of text-image generation. On this slide, we have a compelling visual comparison of image generation outputs from our method and other competitive methods. This comparison showcases the generation of multiple subjects and objects from various prompts. Now, let's delve into the technical details of our proposed method. Our solution is threefold. First, we apply loss terms during the initial denoising steps. This helps to reduce noise and improve the clarity of the generated images. Second, we extract and revise binary masks to create more favorable layouts. This step is crucial in ensuring that each subject in the prompt is represented accurately in the generated image. Lastly, we drive the diffusion process to match per subject XAMs with fixed masks. This step further refines the image generation process and ensures that each subject is distinct and clearly represented. In essence, our method provides a comprehensive solution to the challenges of multi-subject generation. It not only improves the quality of the generated images, but also enhances the ability of the model to handle complex prompts with multiple subjects. Begin a frame. Frame title: addressing challenges. Begin a figure. Centering: include graphics. Width equals 0.8 text width. Height equals 0.45 text height. At src task underscore execution extracted underscore paper underscore data 2405.00791v1 Figures 2405.00791v1 figure 1:1.png. Caption: a tiny visual representation of the challenges faced by various baseline models in generating multiple subjects. End a figure. Begin itemize. Item section 2. Overcoming obstacles. Begin itemize. Item diffusion models, while powerful, often struggle with subject blending and neglection, especially as prompts become more complex. Our method addresses these issues by pulling the generation process and directly editing the latent space, enhancing the ability to generate images with multiple subjects. We've seen this in action with our model's ability to generate distinct subjects in response to complex prompts, as shown in the previous examples. This improvement is crucial for text-to-image models, enabling them to effectively create complex scenes. End itemize. End a frame. Begin a frame. Frame title: our approach. A 3-phase solution. Begin itemize. Our approach. Begin itemize. We propose a 3-phase solution to address the challenges of subject neglect and blending. Item in the first few denoising steps, we apply various loss terms to encourage the XAMs associated with the tokens of each subject to be excited but separate from other subjects. Item after these initial steps, we extract binary masks per object and revise these masks to obtain favorable layouts. The latent space of the diffusion model is then readjusted to match the optimized masks. Item finally, diffusion continues, but the process is driven such that the per-subject XAMs match the set of fixed masks we have previously generated. Item this comprehensive solution addresses multi-subject generation across all diffusion steps, all subjects, and the various spatial locations. End itemize, end iframe, ..